Alright, so this is the Honors Chemistry Section 3.3 lesson video, and this is part 2. Okay, so just like in part 1, you'll want your SI prefixes sheet out, so you either got that from me in class or you can find it on my school website. Alright, so remember, the important thing is you want to have this statement written on your SI prefixes chart, and that is 1 prefix unit equals 10 to the x base unit. Because like I said, a lot of you, this is the hardest part, is getting the conversion factors written. You can follow the golden rule, you're just having trouble with the prefix sheet. Alright, so the difference in what we ended with in the first part 1 lesson video and where we're starting now is in part 1, we went from like milliliters to liters, or grams to kilograms, or centiseconds to seconds. So there was 1 prefix unit and 1 base unit. So we can do those in 1 conversion factor. So if you see 1 prefix, you only need 1 conversion factor. Where we're going to start today is now we have 2 prefixes. We're going from centimeters to micrometers. Okay, so when you see 2 prefixes, you need to use 2 conversion factors, 1 for each prefix. Because notice it doesn't say prefix to unit to other prefix unit, it says to base unit. Alright, so now I will tell you though on the side, because y'all are in honors, you can do these in 1 step, but I've tried to teach it in 1 step before and people don't understand it as well. So I will only teach it in 2 steps. However, if you can figure out the way to do it in 1 step on your own, you're more than welcome to do it that way. Totally up to you. Alright, so first let's write our conversion factors. So the first prefix unit we're dealing with is centimeters. So for right now, just totally forget about micrometers. Okay, we're only focusing on centimeters. So 1 prefix unit, or 1 centimeter, equals, if you look at your prefix sheet, it will tell you for centi, your power of 10 is -2. And then the base unit for centimeters is not micrometers. See, that's why I say just totally forget about that. Because for some reason, everybody wants to go to micrometers. Your base unit is remove the centi and you're left with meters. Okay, so a base unit is just the unit without the prefix. So 1 centimeter is 10 to the -2 meters. So notice this conversion factor doesn't have micrometers in it at all. That's why we need a second one. Alright, so we took care of centi, now we need to deal with micro. So micrometers, we're going to start with 1 prefix unit, or 1 micrometer, equals 10 to the x base unit. So your power for micro, if you look at your SI prefixes sheet, is 10 to the -6. And then base unit for micrometers is just meters. So see, now I have 2 prefixes and I have 2 conversion factors. So now I'm ready to start my problem. And y'all, again, eventually, once you get good at these, you won't sit there and write all this out. You'll just do all that as you're going. Alright, so we're going to start with what we know, which is 0.073 centimeters. And then we're going to follow the golden rule. Remember, the golden rule says whatever unit is in the numerator, it has to be in the denominator to cancel. Alright, so I have centimeters in the numerator, so I'm going to put centimeters down here. I go to my conversion factors to figure out how many, and I can see 1 centimeter equals 10 to the -2 meters. So see, centimeters cancels, but I'm left with meters. So I need to get to micrometers, so that means I'm not done with the question yet. So I keep going. Okay, now I've already used this conversion factor, so I'm going to cross it out so I don't confuse you. Alright, so now we have meters on top, so we're still going to follow the golden rule. So meters goes on bottom. So I'll look up at my conversion factor. It's 10 to the -6 meters. Now let me point something out. A lot of you, when you get to this step, you think because you had the 1 on bottom here, you automatically need to put the 1 on bottom here. Remember, it doesn't work that way. It's all about following the golden rule for units. So I had meters on top, I have to put meters on bottom. When I look at my conversion factor, I can't just switch the numbers if I want to. Once I realize meters goes on bottom, it has to be 10 to the -6 meters. So 10 to the -6 meters equals 1 micrometer. Ooh, sorry, that micro kind of got out of control there. Got a little crazy. Alright, so my meters cancel. I'm left with micrometers, which is what it asked for, so I know that I am done with the problem. Okay, so remember, the way you solve these is any numbers on top you multiply, any numbers on bottom you divide by. So y'all, that's one thing you'll want to check, is even if you understand the process and you can set it up right, don't just copy down my answer. Make sure you get a calculator out and try it. Like, are you getting the same answer? Because it's terrible if you can set it up right and then not get the right answer, because then obviously on a test you're going to miss all of them. Okay, so what you would do is 0.073 times 10 raised to the negative 2 divided by 10 raised to the negative 6. And so when you do that, you should get something along the lines of 730 micrometers. Okay, so we're just adding an extra step to what we did in the first lesson video. In the first lesson video, we finished at one step, so now we're just adding a second. So remember, 2 prefixes is 2 steps. All right, so let's move on and look at some more. I don't know why I just erased my 1 prefix unit equals 10 to the x base unit, because I know I'm going to rewrite it. All right, so I'll just go ahead and rewrite that first. So 1 prefix unit equals 10 to the x base unit. All right, so let's look at this one together, and then you probably want to try these two. Okay, so again, y'all, I can see there's 2 prefixes. I have nano and I have centi, which automatically means I'm going to need 2 conversion factors. All right, so first let's deal with nanometers. So 1 prefix unit, or 1 nanometer, equals 10 to the x base unit. If you look at your prefixes sheet, it will tell you nano is 10 to the negative 9. The base unit for nanometers is just meters. So now I got to deal with centimeters. So 1 prefix unit, or 1 centimeter, equals 10 to the x base unit. So 10, the power, if you look at your prefix chart for centi, is negative 2. And the base unit for centimeters is meters. All right, so I have my 2 conversion factors, so I'm ready to start my problem. So I start with what I'm given, 0.227 nanometers. So I follow the golden rule. I have nanometers on top, so I'm going to put nanometers on bottom. How many nanometers? Well, look at my conversion factor. It's going to be 1 nanometer. And that's going to equal 10 to the negative 9 meters. So nanometers cancel. So now I'm ready to move on, because see, I've only made it to meters. I got to get to centimeters. I've already used that one. So I follow my golden rule. Meters is on top, so I put meters on bottom, so it will cancel. I look over here and I say, oh, it's 10 to the negative 2 meters. Remember, I can't be like, oh, I have a 1 on bottom, I just want to put a 1 there. I mean, you can do that, but you're going to get wrong. Okay, remember, it's not about where does the 1 go, it's about where does the unit go. So 10 to the negative 2 meters goes on bottom. That equals 1 centimeter on top. So if you look, our meters cancel. I made it to centimeters, so I can stop the problem. So remember, multiply across the top. So multiply these 2 numbers, divide by the bottom. So divide by 10 to the negative 2. And once you do that, you should get 2.27 times 10 to the negative 8. Just like that. Okay, so again, just make sure you can get this answer. Okay, because I want you to know the process, but I also want you to be able to get the right answer. All right, so let's move on to the next one. So maybe pause the video and try this one first. And then I'm going to assume you've done that, and now we can try it together. All right, so I have 2 prefixes, which means 2 steps. I have kilo and deci. All right, so let's do kilometers first. So 1 prefix unit, or 1 kilometer, equals 10 to the x base unit. So my power for 10 for kilo on your prefix sheet is 3, and the base unit for kilometers is meters. So now I have to worry about my decimeters. So 1 prefix unit, or 1 decimeter, equals 10 to the x base unit. So your power of 10 for deci on your prefix sheet is negative 1, and the base unit for decimeters is meters. So now I have my 2 conversion factors, so I'm ready to start my problem. So I'm starting with 1.3 times 10 to the 4 kilometers. Now, for some reason, a lot of you try to take this out of scientific notation before you use it. Like you want to move your decimal over 4 places and start with the original number. Don't do that. We're going to get to where we use 6.02 times 10 to the 23 a lot. That's 21 zeros. You don't want to have to get used to writing 21 zeros. Okay, we use scientific notation to cut our time down, not to add more time. Okay, so just leave it like it is. So 1.3 times 10 to the 4 kilometers. Follow my golden rule. Kilometers is on top, so I'll put kilometers on bottom. How many? Well, I look at my conversion factor and I can see 1 kilometer equals 10 to the 3 meters. Kilometers cancel. I'm left with meters, but that's not what I want, so I got to keep going. So I'll put another line. I'm going to cross that one out because I've already used that one. So now follow golden rule. Meters is on top, so meters goes on bottom. I come over here, how many? 10 to the negative 1 meters. And that equals 1 decimeter. So my meters cancel. I now have decimeters like I want, so I'm okay to solve the problem. So I multiply my 2 numbers on top, divide by my number on bottom, and for that one, I got 1.3 times 10 to the 8 decimeters. Alright, so if you haven't tried the bottom one, go ahead and pause it and try the bottom one. And for this one, I'm going to show you how to do it without writing the conversion factors first. We're just going to do it in our minds as we go. Now, if you can't get to that point and you have to keep writing the factors every time, that's fine. But for those of you who can do them in your head, I'm just trying to cut some time down for you. Okay, so we are going from decagrams to megagrams. And just to give you a hint, y'all, decimeters, deci is a D. Deca is a DA. Okay, so that's how you know the difference. Alright, so I'm not going to pre-write out my conversion factors. I'm going to do them in my mind. Okay, so I'm just going to go ahead and start the problem. So I know I have 1,325 decagrams. Oh gosh, sorry, I keep stepping on all these cords up here. It's annoying. Alright, so I'm just going to follow the golden rule. I need decagrams on bottom. So I can use my statement. Is decagrams going to have the 1 or the 10 power? Well, what you have to ask yourself, is decagrams a prefix unit or a base unit? Well, it has a prefix. So decagrams is a prefix unit, so it's going to have the 1. So I'm going to put 1 decagram on bottom. So what does that equal? Well, it equals 10 to the x base unit. So if you look at your prefix sheet, you can see that deca is 10 to the, oh, sorry, I was doing deci. Deca is 10 to the positive 1, and the base unit for decagrams is just grams. So see, I'm still using the conversion factor, I'm just not pre-writing it. Now we made it to grams, but we're not done. We need to get to megagrams, so I'm going to put another conversion factor line. Alright, so we're trying to get to megagrams. I know that grams has to go on bottom, and if I'm trying to get to megagrams, that means my megagrams goes on top, and mega is capital M. Okay, I know I round my capital M's, and some students always like to talk about that, but you can clearly see it's capital because it's much larger than my lowercase g. Alright, so I can tell I need grams on bottom and megagrams on top. Because megagrams has the prefix, it has the 1. And then because grams is the base unit, it's going to have the 10 power. So you look at your prefixes sheet. For mega, it's 10 to the 6. And then you can see that grams cancel. And see, y'all, once you get used to doing these, like I said, you can skip this step and just work it out as you go. So remember, same thing. Multiply the 2 numbers on top, divide by the 10 to the 6 on the bottom. And so for this one, I got 0.01325 megagrams. Alright, so hopefully, if you didn't get this one right, you got this one right, but really hopefully you got both of them right. Alright, so let's move on. I love converting so much personally, but I know a lot of you probably don't share that with me. I'll leave this statement up just in case I need it for the next slide. Alright, so our next one, it says the average speed of, oh, okay, I guess I do need to erase it. The average speed of a nitrogen molecule in air at 25 degrees Celsius is 15 meters per second. Convert this speed to miles per hour. Hint, 5 kilometers equals 3.1 miles. All right, so now I'm going to show you how to convert a double unit. By a double unit, I mean, see how it's meters per second? There are 2 units, and we need to convert both of them. We need to get to miles per hour. All right, so let's start with what we know. So we know we have 515 meters per second. Now, I would highly recommend you write the seconds actually where the denominator is, so you don't forget that it's not in the numerator. Like if you write it like this, it's easy for you to feel like they're both in the numerator. So I would recommend actually write it in the denominator. So we need to change meters to miles and seconds to hours. All right, so I'm just going to pretend like seconds isn't even here right now, and I'm just going to focus on meters. Okay, so we know the golden rule. Meters is on top, so meters goes on bottom. Now, where am I heading with this, though? Because what do we know about miles and meters? Well, I gave you the hint that 5 kilometers is 3.1 miles. So if I'm in meters right now, my first step should be to get to kilometers. Because if I can get to kilometers, then I can get to miles. Okay, so we need to use our prefixes chart. So we're trying to get to kilometers. So remember, I'm not going to keep writing the conversion factors out. We're going to do them in our minds from now on. All right, so I know meters goes on bottom. I'm trying to get to kilometers on top. So remember, it's 1 prefix unit. So the 1 goes with the prefix unit, and the 10 power goes with the base unit. So if you look at your prefixes sheet, the power of 10 for kilo is 10 to the 3. All right, so if you look, my meters have canceled, and so now I made it to kilometers. But remember, I don't want kilometers, I want miles, so I need to keep going. All right, so I gave you the hint, 5 kilometers equals 3.1 miles. So I follow my golden rule. Kilometers has to go on bottom, and so I'm going to use my hint, 5 kilometers equals 3.1 miles. So kilometers cancel. So now I have miles, which is what I want, but right now I have miles per second. We need miles per hour. So this is the new part. We need to change a unit that's in the denominator. The golden rule is the same, it's just the opposite. If you have a unit in the numerator and need to cancel, put it in the denominator. If I have a unit in the denominator that I need to cancel, I put it in the numerator. Okay, so I'm going to keep going. And so since I have seconds in the denominator, I'm going to put that in the numerator. Now, how do we get the seconds to hours? Well, of course, you can do 60 seconds in a minute, 60 minutes in an hour, or you can do our shortcut of 3,600 seconds equals 1 hour. So I'm going to do that way. So how many seconds? 3,600 seconds equals 1 hour. All right, so see my seconds cancel, and now I'm left with hours. And so you can see now I have miles over hours, which is what I want, miles per hour. So now that I have the unit I want, I can stop and solve. So I'm going to take my numbers on top and multiply them, and then I'm going to divide by my numbers on bottom. And so again, y'all, please make sure you're putting this in correctly and get the same answer. So I got 1,149.5 miles per hour. Okay, so hopefully you can get that. Now, like I said, if me not writing the conversion factors is confusing to you, you are more than welcome to always write your conversion factors before you use them, but the sooner you can learn to not have to do that step, the easier these become. Because that's one of the reasons people don't like them, is it takes y'all forever to do them. So the faster you get at them, the more enjoyable they are. That's why I don't mind doing them, because I can just do them real quick. Okay, obviously I slow down when I'm teaching them. All right, so let's look at the next one. It says a car and you're more than welcome to pause it and try it on your own if you want. A car travels 28 miles per gallon of gasoline. How many kilometers per liter will it go? Okay, so we have 28 miles per gallon of gasoline. We're trying to get to kilometers per liter. Okay, so I can use my previous hint up here to get between kilometers and miles. Okay, so I'm going to do that first. All right, so I'm going to change miles first. I'm just going to forget about gallons. So remember, golden rule says if miles is on top, miles goes on bottom. How many? 3.1 miles. And what does that equal? It equals 5 kilometers. Okay, and so if you look, your miles cancel, and now we have kilometers on top, which is what I want. So I have the top, but right now I have kilometers per gallon. So now I need to get gallons to liters. So if you look, I gave you another hint here. For the hint ones, those are ones that obviously you would not need to memorize. Okay, like I don't have this one memorized either. All right, so remember we're changing gallons and it's in the denominator. So the golden rule says if the unit's in the denominator, we put it in the numerator to cancel. So how many gallons? 1 gallon equals 3.7854 liters. So my gallons cancel, and I'm left with liters on bottom now. So see, now I have kilometers per liter, which is what I want. So I'm good to stop and solve the problem. So I would multiply my top two numbers and divide by my bottom two numbers. And once I do that, I got 11.93 kilometers per liter. Okay, so hopefully adding that second unit is not that tricky for you. Hopefully it's pretty easy. All right, so let's move on. And I personally am glad that we're not writing all the conversion factors out. Kind of makes my job a little bit faster. All right, so moving on to these two. So if you haven't tried one yet, you definitely might want to pause and try these real fast. Otherwise, if you want to watch me do one more before you try, that's fine. But either way, I'll assume you've done that. So we are converting 90 kilometers per hour to meters per second. So we have 90 kilometers per hour. Okay, so again, just disregard the bottom first. We're trying to get from kilometers to meters. That's one prefix, so we can do it in one step. All right, so I follow my golden rule. Kilometers is on top, kilometers goes on bottom. I'm trying to get to meters. Like once you get your units set up, the numbers are easy to plug in because we know one prefix unit equals 10 to the x base unit. So 1 kilometer, because it has the prefix, is 10 to the 3 meters because I pulled that from my SI prefixes sheet. All right, so kilometers cancel. I now have meters in the numerator, which is what I want, but right now I have meters per hour. So I need to change my hours to seconds. So I'm going to put another conversion factor. Now remember, you are more than welcome to do 60 seconds in a minute, 60 minutes in an hour. I like to just do it as one step and say 1 hour equals 3,600 seconds. So my golden rule for the denominator is any unit in the denominator that I need to cancel, I put in the numerator. So we know we have hours, we're trying to get to seconds. We know 1 hour is 3,600 seconds. So if you look, my hours cancel, and I'm left with seconds. So now you can see I have meters per second, so I'm ready to solve. So I'm going to multiply my numbers on top and divide by my number on bottom. And so for this one, I ended up getting 25 meters per second. All right, so again, if you haven't paused and tried one, definitely try this one. You really need to try these on your own. All right, so let's go for it. So we are starting with 78 hectograms per microliter, and we're trying to get to grams per liter. Okay, so y'all, again, don't freak out when you see all these units. Just disregard the bottom. We're trying to get from hectograms to grams. That's a prefix unit to a base unit. It takes one step to do that. Okay, so we follow our golden rule. Hectograms is on top, so I'm going to put it on bottom. I'm trying to get to grams. And so then we follow my little statement that I told you to write on your prefixes sheet. One prefix unit, because hecto is the prefix, is 10 to the x base unit. So our power for hecto is 2. So hectograms cancel, and I'm left with grams, which is what I want. But right now I have grams per microliter. I want grams per liter. So now let's focus our attention on the bottom. So we're trying to get from microliters to liters. So again, that's a prefix unit to a base unit. That takes one step. Alright, so remember, golden rule is if the unit's in the denominator, to cancel it, we put it in the numerator. So we have microliters, we're trying to get to liters. So remember, it's one prefix unit, so 1 microliter is 10 to the x base unit. If you look at micro, it's 10 to the negative 6, and my base unit is liters. So if you look, your microliters cancel, you're left with liters. So see, we have grams per liter, so we are ready to solve. So I multiply my top two numbers and divide by my bottom number. And so for this one, I got 7.8 times 10 to the 9 grams per liter. Okay, so that is how you solve when you have multiple units. You just convert one at a time. Not a big deal. All right, so let's move on. There's my answers. All right, so it says, whoop, oh, thought I clicked enough. All right, so it says Earth's oceans contain approximately 1.36 times 10 to the 9 kilometers cubed of water. Calculate this volume in liters. Okay, so y'all, this is a tricky one that involves a lot of conversion factors, but the new thing on this one is one of my units is cubed. Like, we're not just going from kilometers, we're going from kilometers cubed. Okay, so how in the world are we going to get from kilometers cubed to liters? Well, I gave you a hint. 1 milliliter equals 1 centimeter cubed. All right, so in other words, in my mind, that means, okay, I need to go from kilometers cubed somehow to centimeters cubed, then I can get to milliliters, then I can get to liters. Okay, so don't worry about the cubed yet. And sometimes, y'all, the tricky parts about these is planning the problem. Like, what am I going to go to? Like, what are the steps I'm going to use? So I'm going to get from kilometers to centimeters, from centimeters to millimeters, milliliters, and then milliliters to liters. All right, so let's start, and I'll try to go slow. So we have 1.36 times 10 to the 9 kilometers cubed. All right, so for right now, just pretend like the cubed isn't even there. I'll show you how to deal with that in just a second. So we're trying to get from kilometers to centimeters. That is two different prefixes, so we have to do that in 2 steps. Because remember, it's one prefix unit is 10 to the x base unit. So first, I'm going to deal with getting from kilometers to my base unit. Okay, so golden rule says whatever's in the numerator goes in the denominator. And so I'm going to go from kilometers to meters first. So I follow what my formula says. One prefix unit is 10 to the x base unit. In this case, it's 10 to the 3. Now this will cancel out 1 of the kilometers. But we have 3, because kilometers cubed is kilometers times kilometers times kilometers. So how we cancel out all 3 is we take the entire conversion factor and cube it. When you do that, it cubes the number, it cubes the unit, it cubes this number, and it cubes this unit. It cubes everything. Okay, so now I have canceled out a kilometers cubed because I've cubed this entire thing. All right, so now I've gotten to meters cubed, technically. I'm still trying to get to centimeters cubed. So I follow my golden rule. Meters is on top, technically meters cubed. So I'm going to put meters on bottom. And now I'm just trying to get to centimeters. So centimeters on top. So remember, it's one prefix unit. So centi has the prefix, centimeters, has the prefix centi. So 1 centimeter is 10 to the negative 2 meters. And so again, I'm pulling that from your SI prefixes sheet. However, I'm trying to cancel out a meters cubed with just a meter. So again, I'm going to cube the whole thing. All right, so remember, y'all, that means you're cubing the numbers and the units. Now, of course, 1 cubed doesn't change, but you're cubing your numbers too. So you're going to want to be real careful when you're checking your answer with mine to make sure you're putting in the calculator right. Okay, so now we made it to centimeters cubed. So I told you 1 centimeter cubed equals 1 milliliter. Okay, so we follow our golden rule and we put our centimeter cubed on bottom because of course we want to cancel that out. And that equals 1 milliliter. So see, we're almost there. And y'all, they're not all this difficult. This is just a super awesome one. All right, so now we have milliliters, but we're still trying to get to liters. So we got to go back to our SI prefixes sheet. And what I want you to notice is, y'all, I'm not cubing anymore because this unit itself already was cubed. So there was no point in cubing this. All right, so I made it to milliliters. Milliliters is also not cubed, so I'm back to normal. So I need to get from milliliters to liters because that's what I want in my answer. So look at your SI prefixes sheet. One prefix unit, which is milliliters, is 10 to the x, in this case -3, of our base unit, which is liters. So my milliliters cancel. I'm left with liters, which thank goodness, that's what I want. So I am good to calculate. So y'all, when you calculate, be careful. You are going to take your original number and you're going to multiply it by 10 cubed, but that is also cubed. Okay, it's easy for you to forget that you cubed it when you're plugging this in. All right, and then you're going to divide by 10 to the -2, but you need to cube that also. Okay, so remember, even though the cubed is way up here, it applies to everything in the parentheses. So let me just put what I got up here and then just play with your calculator a little bit and make sure you get the same answer. So I got 1.36 times 10 to the 21 liters. Like that. Okay, so again, if you're having trouble getting my answer, make sure you're cubing. One thing you could do is, like, if you're not sure, like one thing to kind of help you out is you can be like, okay, I have 10 to the 3 to the 3. What does that equal? And then you can plug that in right here. Or I have 10 raised to the -2 and cube that. You know, what does that equal? And I can plug that in down here. So if you want to do that instead of having to, you know, use a bunch of parentheses and things like that, because depending on what calculator you have, it's easier to do powers than like some other calculators. You know, so it's just, like I said, just kind of play around with it. See, my calculator makes it pretty easy to, you know, just plug it in. But, you know, just play around with it until you can get the right answer and figure out how to put it into your calculator. All right, so I'm going to erase and let's try a couple more. And don't forget to be trying some of these, okay? It doesn't help you to just watch me do all of them. All right, so our next one, it says, if the volume of an object is reported as 5 feet cubed, what is the volume in cubic meters? And so I gave you a hint, 1 inch is 2.54 centimeters. So again, y'all, let's plan our way through this problem. We are at feet. We know how many inches are in a foot, so we can go from feet to inches. I told you how many centimeters are in an inch, so then we can get to centimeters, and then we can use our SI prefixes sheet to get from centimeters to meters. So like I said, sometimes it just pays to take a second to plan your way through the problem. All right, so I'm going to start with 5 feet cubed. All right, so first of all, we live in America, so unfortunately we all know that there are 12 inches in a foot, because why we don't just use meters, I don't know. Okay, so golden rule states since feet is on top, I'll put feet on bottom, and I'm trying to get to inches. So we know 1 foot is 12 inches. However, I'm trying to cancel out a feet squared, feet cubed, so I need to cube this whole conversion factor. All right, so remember that's cubing the 12 also. All right, so now my feet cubed have canceled. I am to inches cubed. So I'm ready to move on. So I know there's 1 inch and 2.54 centimeters. So inches is on top, so I'm going to follow the golden rule and put inches on bottom. How many? 1 inch. What does it equal? 2.54 centimeters. So if you look, my inches cancel, but remember, technically we're trying to cancel an inch cubed. So I also need to cube this conversion factor. So remember, that is cubing the number also. So now I made it to centimeters cubed, but we still need to get to meters cubed. So this is where I would use my prefixes sheet. So I know I have centimeters on top, so So I put centimeters on bottom to follow my golden rule. I'm trying to get to meters, and so I know one prefix unit is 10 to the x base unit, so 1 centimeter is 10 to the negative 2 meters. And again, y'all, I'm just pulling these from your SI prefixes sheet. However, I'm actually canceling out a centimeter cubed, so I need to cube this one as well. So for this one, I literally had to cube everything because I was trying to end with meters cubed. And y'all, please, please make sure you remember that all of these numbers have been cubed. Not this one, but all of these have. All right, so since all my numbers are on top, I'm going to multiply all of them. And so please just make sure you can get the same answer that I'm getting. So I end up with 0.14 meters cubed. And that's how you do it. Okay, so the bottom one, definitely try this one on your own. It has double units and one of them squared. Okay, so try this one on your own. It's going to be fantastic. Try this one on your own, and then we will look at it together. Okay, but I'm going to assume you've done that at this point. So we are starting with 50 meters per second squared. All right, so I need to change meters to kilometers. I need to change seconds squared to hours squared. So I'm just going to forget about seconds squared right now and say, okay, I'm changing meters to kilometers. I can do that in one step because it's one prefix, kilo. All right, so I follow the golden rule. Meters is on top, so I'm going to put it on bottom. I'm trying to get to kilometers. I know one prefix unit is 10 to the x base unit, so 1 kilometer is 10 to the 3. That's for my prefix sheet. Meters, base unit. So my meters cancel, and I'm left with kilometers, which is what I want on top. But I have kilometers per second squared right now. So I need to keep going. All right, so remember, you can do 60 seconds in a minute, 60 minutes in an hour, all you want to. But I'm going to shorten it to 1 hour is 3,600 seconds. So seconds is in the denominator. So to follow golden rule, I'm going to put it in the numerator. I'm trying to get to hours. So I know 1 hour is 3,600 seconds. But I'm trying to cancel out a seconds squared. So I need to square this whole conversion factor. Now notice I didn't square this one because I was just going from meters to kilometers. I didn't need to square that one. But I'm going seconds squared to hours squared here. So my seconds cancel. I'm left with hours squared on bottom. Remember, the squared goes to everything inside. And so then I solve. So to solve this, you'll want to do 50 times 3,600 squared though. Like, don't square the 50, just the 3,600 squared, and then divided by just 10 to the 3. Okay, you don't need to square that. And so when I did that, I ended up with this right here. And so again, y'all, for these, some of the trickiest things that I've noticed over the years is plugging it into the calculator. Okay, so just be really careful of that. All right, so for our second lesson video, we're going to end right here, and we will pick up and finish the rest of the section in the third video, part 3.